Alright, so here we're going to go a little bit more into detail about the table values and maybe graph the parent function just so we kind of get a good glimpse of how quadratics look like. So standard form you guys are familiar with. This is ax squared plus bx plus c. Vertex form is, let's put f of x there. F of x is equal to, for vertex form, you guys have done this in your Google search hunts, this is a parentheses x minus h squared plus k. And for the equation for a parent function, we're going to have what we saw earlier, which was f of x is equal to x squared. So that's all the type of equations we have. Today we'll be working out of the parent function to just see what the quadratics look like. So let's plug in some values for x. So here's my equation. I'm going to plug in my value -3 into the function. I have -3 squared, which gives me 9. At -2 squared, I have +4. I know it's negative, but negative times negative is positive. -3 times -3 gives you +9. -1 squared gives me 1. 0 squared gives me 0. So now here we start to see the kind of weird shape that we haven't seen before of functions. At 1 squared, we get back up to 1. So it looks like these values were going down. And then here at 1, we start going back up. At 2 squared, we have 4. And at 3 squared, we have 9. So notice how the values were like high, starting high, drop down to 0, then they bounce back up. Alright, so now let's try to graph this. Let's try, this is going to be our y, this is going to be our x. I don't think this goes up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's pretend it does. -1, -2, -3. So here's one point, -3, comma 9. Here's your second point, -2, comma 4. And your third point, 1, -1, comma 1. And 0, comma 0. Again, 1, comma 1. 2, comma 4. And then 3, comma, let's see right here, 3, comma 9. So I plotted all the dots, and it kind of looks like it might be a V shape because my dots are kind of like spaced out. But in reality, this is a parabola. It's pretty rounded. It's more like a U shape. So this is what the parent function of quadratic formulas look like.